we'll discuss another method of finding the roots of an equation. So this method belongs to the bracketing method, and it's called the false position method. Okay, so what is the difference between this method and the previous method? So actually the procedure is basically the same. They only differ in finding the roots of the equation for XR. Now XR will be calculated as XU minus f of XU times XL minus XU divided by f of XL minus f of XU. Okay, and the sequence is just the same. First you chose XL and XU, calculate XR, and then determine the error. If the error is greater than the stopping criterion, proceed to the second iteration, and so on. Okay, so nagikan. So if we note that this is the graph of the equation, this is your roots, right? And you chose a value of the bracket or the interval. Okay, so this is your XU. Okay, and then sorry, so doon kayo sa middle na. Okay, and kung bisection method mo gamiton, you get the middle point. This will be your XR. This will be your XR. Now the problem with the bisection method is yung gina-half ang imong error, tudugay ka mo converge. So ang false position method, yung gi-compare ang, by the way, this will be, kaninga point will be your f of XL, and kani f of XU. Okay, so sa false position method, nakita niya nga if you connect this kani nga point o kani ruler. If you connect these 2 points, kani okay. By the way, this is the actual location of the root. Okay, so nakita niya nga ang value sa imo ang f of XL is mas shorter compare sa f of XU. Sa may implication na is probably mas duol ang f of xl sa imong root. Okay? So, instead na kanimong gamiton using the bisection, ang imong buhaton karon is kani nga intersection sa line, kani nga root ay kani nga point mo ni ang imuang gamiton na XR. Okay, XR. So mao ni siya. Mao ni nga equation. So giunsa man na sa pagkuha, using the principle of similar triangles, nakaduha ka triangle kani o kaning larger triangle. So imo na siyang equation proportion kani nga length kani nga length of kani, so f of xl over kani nga length, that is xr minus xl is equal to kani nga length of over ani f of xu over xu minus xr. Okay, but take note na kani nga value naa sa ubos sa imo ang x-axis, therefore negative ni, no? And then imo na yung i-cross multiply, you will get xr f of xl minus xu f of xl is equal to xr well xu minus xl f of xu. Collect nimo ning na mga xr, so you will have diretso na lang ni himo ning xu f of xl xu f of xl minus xl f of xu divided by f of xl minus f of xu. Okay? Actually, pwede naman kadiritaman. Pero, mo ba na yung form? So, atong baton na to is we will obtain that form. So, bulago ni siya xu minus xl f of xu over okay. So, na ako ni. Okay. Wala pagyapon na obtain. So, pag obtain na mag-add daw ka og xu dire plus nag-add man kag xu di mag-minus kung ka dire xu para the same, and then i-add ng dulo. So you have xr xu plus f of xl, so you have XU f of XL minus XL f of XU minus XU f of XL plus XU f of XU. Okay? Tayo makancelan ni kani palain. So, mabili ni mo is XR is equal to XU minus man dere. So, minus na to ni. Minus f of XU. I-collect na to na minus XL minus XU over okay. So we have derived the formula for finding the root ng XR. So instead sa bisection method, instead na kami XL plus XU over 2 imong gamiton, ano imong gamiton? And we'll find out that mas dali ni siya nga method. So atong buhaton, atong solve tong previous example using this method. Okay? So okay, so this is the example from the previous method. Okay, so the first step is again select XL and XU. So from previously, ang gamit nato is XL equals 12 and XU is 16. Then solve XR using this equation. You have 16 minus, now f of 16 is negative negative 2.2688 12 minus 16 over f of 12 is 6.0699 minus okay, XR will be 14.9113. Okay. Okay. So we cannot solve the error because first iteration pa man eh. So we proceed with second iteration. But again, we will check if f of XL times f of XR so ang f of panin mo ang f of 14.9113 so pila na siya. F of 14.9113 is negative 0.2543. Okay? So, solban ba? Okay, so sakto na. F of 14.9113 is negative 0.2543. Okay? So 6.0699 times negative, answer is less than 0. Okay? So since less than 0, set x u equal to xr. So our new interval will be xl equals 12, xu equals 14.9113. Okay? And then calculate xr2. This is xr1. You have xu 14.9113. By the way, ang atong stopping criterion is again less than 0.5% minus f of 14.9113 is negative 0.2543 times 12 minus 14.9113 over f of 12 times not times, minus f of negative 0.2543. Okay? So ang XR ni mo ani will be 14.7942. 7942. Okay, 7942. So calculate na to ang error. Error will be 14.7942 minus old 14.9113 over 7942. Okay, 14 point. Point 79%. Okay. Okay, so ang error niya, no, after second iteration becomes 0.79%, but the stopping criterion is 0.5, so we will go for third iteration. Okay. So check f of 14.7942. Okay, so f of 14.7942 is negative 0.0273. Again, test whether f of xl times f of xr. So you have xl is 12, 6.0699 times negative 0.0273. The answer is less than 0, therefore the new interval is 12, xu is 14.7942. Okay, calculate xr3. You have minus negative 0.0273 times XL 12 minus 14.7942 divided by 6.0699 minus negative 0.0273. Okay? Okay, so XR3 will be 14.7817. Okay, so again, next step is calculate the error. You have 14.7817 minus 14.7942. So this is, you multiply this by 100%, you will get 0.08%. Okay, so the error now is less than 0.5, therefore the calculation is terminated. So you can see that after third iteration, you have only arrived at the final value, which is 14.78187. As compared to the bisection method, it takes 6 iterations. So the false position method is a much better way. However, there are certain cases that the bisection method also is much better than this method. Okay, so this is the diagram of the calculation of the roots for bisection and false position. So as you can observe, mas paspas may converge ang false position. However, it's not all the time ninana po ng behavior. Say for example, this problem. You have f of x is equal to x raised to 10 minus 1 between 0 and 1.3. So this is your XL and XU. So if you solve this one using bisection method, this is the result. After 5 iterations, the error, approximate percent relative error, reduces to 4%. Okay, so the value is, the root of this equation is 1.015625. However, for the false position method, after 5 iterations, the approximate percent relative error is still 17.1%. So dako gyapon siya, meaning wala pa sa ni converge. So tan-aw nimo siya, mo po na nahitabo sa imong calculation, no? First iteration, and then second, third, fourth. And then tanaw nimo napaday diri ang root, no? So there are times na mas dali pod ang bisection method.